Hey there, welcome back. 9-2, we're talking domain of logarithmic functions, and in this video it's going to be very, very short. I'm just going to cover a couple of examples of kind of weird examples of finding the domain of logarithmic functions, okay? All right, so here we are asked to find the domain of a logarithmic function in set and interval notation, and we're given the function g of x is equal to log of x squared plus 10x plus 25. So logarithms, their argument must be greater than 0. So I'm going to go ahead and I'm going to take the argument, and I'm going to set it greater than 0. Now, since this is a quadratic, I'm going to go ahead and switch to an equal sign, and then I'm going to solve the quadratic equation to find the critical numbers. So x squared plus 10x plus 25, that is x plus 5, x plus 5. Okay, and notice I have two of the same binomials. So x plus 5 equals 0 or x plus 5 equals 0. So I get two of the same solution, which is negative 5. Okay, so I have this weird case. I don't have two critical numbers. I only have one critical number at negative 5, and I have multiplicity. Now I'm going to tap into your knowledge about quadratics and parabolas. Now what we could have is we could have a parabola that has a vertex at negative 5 facing upwards like this. Okay, or we could have a parabola that is facing downwards like this. Okay. And I bring this case up because we're looking for values that will make our argument positive. I want the values to be positive. So what we would prefer is the case on top. I would prefer this situation. So I have values, right? So every single value would be a valid, I guess, domain value. Okay, because our argument would be positive except for negative 5. In the case below, all those values are going to be negative, so they won't be part of our domain, and we would be left with no values, right? And that'd be a pretty lame function because you can't do anything with it. Okay, so what we're going to go ahead and do is we're going to test two values. Okay, so I'll test 0. 0 is over here. So when I plug in 0, I get 0 plus 0 plus 25. So 25 is greater than 0. Yes, this is positive. So it's looking like this case where it's both positive. And then I'm going to go ahead and pick a value. I can pick, I guess, negative 6 is fine. So negative 6, if I plug that in, we get 36 minus 60. 36 minus 60 plus 25, and this would give us 61 minus 60, right? Yes. Okay, so positive 1, so it's positive. Okay, so therefore, I know that our domain is everything except negative 5. Okay, so x such that x is less than negative 5 or x is greater than negative 5. Okay, and interval notation, that's going to be negative infinity to negative 5, union negative 5 to infinity. Okay, so that's kind of the weird case number 1. The second case, here I have kind of a different type of a result. So let's look at it. X squared plus 16 is our argument. Okay. Notice how I don't even pay attention to the rest of the function, right? It all kind of doesn't matter. I want that argument to be greater than 0. So we'll go ahead and solve this. So x squared plus 16 is equal to 0. Giving us x squared is equal to negative 16. Now, I'm going to go ahead and take the square root of both sides, and what I hope you notice is that we get plus or minus 4i, right? When I take the square root of negative 16. Okay, so what this means is that there's no critical numbers. Okay, I have no values where it is 0. And kind of what you can think about it too, I mean, think about this expression here, x squared plus 16 is greater than 0. Isn't that expression always greater than 0? If I plug in anything into x, right, this is always going to be positive. So positive plus a positive is positive. So we're good. Okay, so what is our domain? Well, in set notation, it's all real values. So x such that negative infinity is less than x, which is less than infinity. And in interval, negative infinity to infinity. And there you have it. Okay? All right, I do have a practice problem for you because I'm nice like that. Here you go. Please go ahead and try this one. Okay, hopefully you pause the video and you've given it a go. Here is the solution. Okay? All right, and that is it. That is finding the domain of logarithms. Catch you next time. Peace.